We were waiting for the ever-elusive beat. That's when it dispenses. Where were we at? Who said what? Parker, which one?
16.
Number 16, boys and girls. One of the most common issues it seems we always have here. Parker, do we have any issue with why it's a 3? Okay, there's your beat. I mean, you know this is 3, right? Because the 2 crosses off with that. You get a 6 up or a 3 up there. Did you get that part, Parker? Alright, so where do you go from there? Just push in the little button. Push your cup all the way back. Like you're at McDonald's. Farther. Oh, you're Oh, anything better than that. So, Parker, walk me through here. What was your next step in the thought process of this whole thing?
Well, I did the X's.
So what'd you do with the X's?
I added them, I guess.
Well, yeah, you gotta, what happens to this -2? That's the issue. Somebody? There's more than one way to skin this cat, that's why I'm asking you, because you could do this multiple ways to get the right answer as long as you follow the right procedures there. Mr. Westphal, what would you do?
Okay, so I added -2 up to the bottom, and then I got x
Well, you have to tell us why you can add those 2 together.
because the top one is a negative.
Right, when you move this to the bottom, it becomes a +2. So x squared and another x squared from the top gives you x to the 4th. That's why you can add them together. Then, that means you have 4 x's on the bottom. That's your x to the 4th. And on top you have 5 of them. So what's going to happen is, 1 for 1 they're going to cross off until you're left with just 1 x left on top. That doesn't cross off with anything. Correct? Here you have 2 y's on top and 1 y on bottom. This y is going to cross off with one of those y's, so you're still left with a y. And you still have this 3 over here. You don't have to put it over 1. Everything on the bottom crossed off. You definitely, if everything on top crosses off, you have to leave the 1 on top, but you certainly don't leave it on the bottom. Brant.
I think it's a 3.
How did I get number 3? Again, I would suppose you guys are, if you're struggling with this, writing yourself some notes to use tomorrow on the test. That's what I would do. Brant, did you sketch it out? Alright. So here it is. A vertical yardstick cast a 24-inch shadow. So did you draw the yardstick?
Yes.
And you drew its shadow.
No.
Doesn't it say it has a shadow? I'm not sure how you can forget what it tells you. And you label that. This is 24 inches. A yardstick is how many inches tall? 36. Okay. And then it says at the same time a flagpole casts a shadow that is 16 feet tall. And they want to know this. So how does one go about doing that? Wade, we make a ratio box. What are the categories of my ratio box? What do I put up here? Yeah, this is the small triangle, which would be the yardstick. This is the big triangle. And you're comparing its height to its shadow, or shadow to height. It doesn't matter the order you put them in, they'll all work out. So the small one is 36 over 24. The height is 36. Shadow is 24 inches. The big one, we don't know the height, but we know the bottom is 16 feet. Just knowing that this answer is going to be in feet because that bottom is in feet. So from there, we just make equal fractions. 36 over 24 equals x over 16. The easiest way to solve that, you can always cross multiply, but you work with some bigger numbers. You might as well do what? Amelia?
It is.
Yeah, you might as well take this first fraction. What number goes into both of those? 12. Divide them both by 12, you get 3 over 2. And then what happens? 2 times x is 2x. That equals 3 times 16, which is 48. Divide by 2. Divide by 2. 24 feet tall. So, in my notes for problem number 3, I think I would be jotting this stuff down. I draw the things, make the ratio boxes. Really, the math is not that complicated, nor is the thought process there. Carter A.
How do you get number 5?
Oh, I love number 5. Is it on this page or is that on the other side? The speedometer on Murray's car shows the speed in both miles per hour and kilometers per hour. Using 1.6 kilometers per hour as the equivalent for 1 mile, when find the miles per hour at the rate that is equivalent to 80 kilometers per hour. So all they are asking you to do is do what? Change 80. You are changing 80 kilometers per hour, and you want to make it miles per hour. How do I do that? Unit multipliers. Which of these am I trying to cross off? Am I getting rid of the hours? Am I getting rid of the kilometers?
Kilometers.
So where does it have to go? Right. And what am I changing kilometers in? Miles. And then we just have to make sure you get the conversion right. They say 1.6 kilometers is the same as 1 mile. So 1.6 kilometers is the same as 1 mile. This is my unit multiplier. What do you end up with? Kilometers cross off, which is good because I want miles per hour. And I just am going to then divide 80 over 1.6. How many times does 1.6 go into 80? Decimal over. 16 into 800 is 50. Yeah, 5 goes. 50 miles per hour. Can't go wrong with the beloved unit multiplier / conversion fraction / whatever you want to call it, whatever name works. It will serve you well the rest of your life if you learn how to cross off labels. Abram?
What was 4?
Number 4 was $12.30. Carter Westfall.
How do you get 1 and 2?
Well, let's just do one at a time.
Got it.
Don't overwhelm the teacher with too many questions all at once. Did you draw a percent box?
No.
You know what this is? A sigh of exasperation. It's really pretty. It's not. Okay. Now notice, children, this is not an increase in percent thing. It doesn't say the bill went up, whatever. You are splitting a bill into parts. It's this plus this is total percent. And what 2 things are you adding together? You've got parts. Adding to it labor, and you get total. And this is the actual dollar amount. What do we know? $120 repair bill, that's my total, included 36 for parts and the rest for labor. Can you figure out what labor is based on that? Evelyn, what's labor? How much is labor? Oh boy, you can't do that.
What?
How much would labor be?
$94.
$84. If you actually do the math, it's only 84. Unless you're borrowing and you're carrying. Total is 100%, and I am looking for the percent for labor. That's what I'm looking for right there, Mr. Question Mark X. And just like we did the little, can you see where ratios are important? Because we've done it for like the last 17,000 problems. What number over 100, ladies and or gentlemen, equals 84 over 120? Just like before, you can make your life easier, Evelyn, by reducing this fraction, just to make your numbers easier, what can you do to them? Divide them by,
42.
well, cut them in half, sure, why not? 62 and, oh, I'm sorry, 42 and 60, right?
Yeah.
Sorry. But then you could cut them in half again and get 21 over 30. And then what can you do to 21 and 30? Divide by 3 and get 7 over 10, right? Which is nice because to go from 7 to 100, you can simply multiply by 10. Multiply 7 by 10, you're going to get, no, that's what this is, 70. 70% of the bill is labor. And that's mostly because of the exorbitant cost of healthcare, children. I hate to get political on them. And 2. 5 students measured the mass of a rock, the reading from blah, 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 the mean. What part don't you get on number 2, sir?
Never mind.
Did you put them in order from least to greatest, first of all?
Yeah, because I multiplied. I divided from.
Did you get the first part right? Did you get the second part right?
Wait. 2. I got the first part right.
You got the average right, but you didn't get the median right?
Yeah. I didn't get the mean right.
You didn't? Well, that's the first part. You add them together and divide by what? 1, 2, 3, 4, 5. Does somebody need me to do this? I won't. There's the whole data. But the first thing you have to do is put them in order, at least for the median. You don't have to do that for the average, but for the median. The smallest one is what? 97.3, 98.4, 98.6, 99.0, and 99.2. Median is the one in the middle, and that would be right there. Add them all together, divide by 5, you're going to get whatever the average is going to be. Smile, kids, you're not kidding. No, Jacob, that's a forced smile at best. No other ones of all 20 problems. Carolyn!
17.
Love it. You are my next hope to get that P53.6. 17? Put it over your eyes. Oh, yeah. This is a good review, too. Here is our issue. We don't like negative exponents. Carolyn, how do we fix negative exponents? What's that? That already is a fraction. With fractions, how do you fix negative exponents? Tyler?
Flip the fraction over and make the fraction.
Yep. It's a simple little fix. All you do is flip that over. Then it becomes a positive exponent. Notice it has nothing to do with making this negative or positive. And then it's just a matter of anything to the first power is itself. So you end up with 3/2 minus 2/3. That is actually the problem there. And then you can just make them common denominators, which is 4 6 on top and 9 6 up there. Do the subtracting and it looks to me like you get a 5.
Oh,
Did I do that wrong?
no,
Did you do it wrong?
not my paper, but my head right now I did it wrong.
There's a reason why we do stuff on paper.
Yeah.
My ultimate goal really is for you to do all of your math in your head, like when you're old enough. But unfortunately, that just ain't gonna happen just yet. You have to get where you can multiply the double digits in your head. Like 99 times 7. Wait, 693, isn't it? Well, that one should be easy. 99 times 7?
Good job.
It's the same thing as 100 times 7 minus 7. Right? Carter,
I didn't get number 6.
6 again?
No, I didn't do 6.
But you didn't do 6.
We didn't do 6.
We didn't do 6.
I did 6.
What is the length of a diagonal of a rectangle that is 24 by 10 inches wide? 10 inches by 24. You drew this, Carter?
Uh-huh.
And if you're looking for the diagonal, what do you suppose you're going to have to do to solve that? Or what do you suppose, what thing do you think you're using to solve that? We're not looking for area. Carter Westfall, what's your... There you go. This is a right triangle, so you use the triangular theorem. But if you look, there is no 1024 up there. If there is no 1024, yeah, you need to see if you can come up with a smaller triangle that is the same ratio as that. Cut them both in half, and this is a 5, 12 triangle. Is there a 5, 12?
Yes.
And what is its diagonal? Or
13.
13. But 13 is not my answer because that's the small ratio. I have to redouble it to get what the big one would be.
26.
Again, not one of the world's most difficult problems. Carter
I
Westfall,
get 7.
how do I get it?
Yeah.
Number 7, solve and graph the solution on a number line. So you wrote the equation down, or actually it's an inequality, but you
Yeah.
solve it like an equation. And what did you do first, sir?
Let me see. Let's write this down on my paper. Let me use my notes. Okay. I wrote it down. Then I looked in the book and it had like X boxes and had plain boxes. And so I put the one X
There's
box.
an Xbox.
Look at it.
I don't know. First
There's
of all,
there's an X
I would look at my
inside.
notes under inequalities before I look at the book. But you know, is there any point in me explaining anything if you're just going to look at the book? Not that I'm against it, but you should have notes that maybe would help you better than maybe the book would. You might think. So what did you do then with all your boxes?
Well, I got it right in the left direction and it opened. Instead, I didn't put it on one.
Well, that's kind of an important thing. How do we come up with the 1 there? How do we?
Solve for X.
Yeah, you just solve for x like it's an equation. Get rid of this 2 by doing the opposite, which is subtracting 2. So x is less than 1. Here at 1, it's an open circle because there's no equal sign underneath there. And then the arrows show that it's less than, which is this little arrow which is the same as this little arrow. Look how they look alike. There it is. Carter Westfall?
I get 8.
Again, I would be looking at my notes. Did you write down did you write down what slope intercept, the general equation for slope intercept is? I mean, you got to start with the basics. What is, and this is what I have in my notes, what is the slope intercept equation? Yeah?
Y
Y what?
Y equals Y m sub x plus b.
B. Where the letter B is where it crosses the y-axis. Where does this cross the y-axis? Right here at where y is -1. So that's what the letter B is. Now you just need to figure out what the slope of the line is. And you've got your answer. How do you find slope? Well, I believe they give you a couple points. There's one here and there's one here. If you make this triangle, slope is the height of the triangle over the width of the triangle. How high is that triangle?
1
How wide is it?
2.
Is it going uphill or downhill? Uphill, so it's a positive slope, so you don't have to change it. Y equals 1/2 x minus 1. I struggle at some points knowing that we do this on a daily basis, and I don't very often get questions about it every day. When it comes test time, all of a sudden we don't know how to do it. Your book is built on repetition, 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 so that really, I mean, you should spend, if you're keeping up with your daily stuff and understanding it every day, I mean, you shouldn't have to study it all for the test. But that's kind of the way the whole book is built. Because every day is repeating the other days and every day is building up on it. So if you feel overwhelmed on test days, it's probably because you're not spending time daily to figure out what's going on. That's usually what most people say. That is a great point.
That is a great point, Mr. Hahn.
Not Mr. Hahn, just that's a great point.
That's right. Don't go over and above. I like that. Any other ones on all that? All 20 problems, that's all we got. Carter Westfall.
Okay, I didn't get. I'm trying to figure
You're just asking the questions that about 8 other people aren't, so don't ever be afraid of asking it. You're not the only one I'm saying that probably didn't get these right. I'm saying here.
Well, I just want to know how I got them and didn't get them. And
That's why we do this.
I didn't get 12.
It's a good review for everybody else as well. Despite if they think that it's not. 12. Anybody know where 12 is?
The talking
Number 12. Oh, we gotta look at some shape.
It's
If angle B measures 61 degrees, the measure of DAB. If B is 61 degrees, I want DAB. I want this angle right here. 61 degrees DAB. One thing that you may or may not recognize with this is that a parallelogram is, and especially that one, is nothing more than 2 parallel lines that, believe it or not, are cut by a transversal. Yes? Okay. I mean, that's one thing to look at there. How in the world can you figure out what this angle is here?
You know.
Evelyn?
Well, you know D would have to be 61 degrees too,
Why?
because they're opposite. I forgot what the fancy term was. Okay, hold on.
Yeah, this is another transversal here.
That thing.
They would be this way, where this doesn't, how is that? Oh, they are opposite angles. Did we do that on parallelograms? I believe we
We
did.
did opposite.
Opposite angles are equal, so this is 61 degrees, but that's not what it asked me. It asked me about this angle here. Evelyn?
You add those together, and then you know the parallelogram is 360 degrees in total. So you add the 61s together.
Somebody open up your notes on your parallelograms. I want to see what you have written down on the parallelograms.
What? Gosh.
Show me your notes under parallelograms, and let's see if we don't have some sort of note that discusses this sort of thing. Because it seems to me, I get classes mixed up in my head.
Oh, goodness.
we don't have no.
We don't have no.
Yes, we
Yeah,
do.
we do.
I have
We
them
do.
right here.
Let's put it under.
That's the
Yeah,
mine are too sloppy.
It's just that area.
Is that the only parallelogram? How about quadrilaterals? Is there something under quadrilaterals?
Oh,
Yes. No. Yeah, I know. Yes.
Because if not, we might just jot this down here.
It's the.
Yeah.
What lesson number does that say on it? I may have to jot you down a couple notes here to put under. Open up your notes under quadrilaterals.
It says investigation 3 and 54. And it's plus 54.
I have a way to do
Oh, I have two.
Which one? 54? Do you have another set of notes on parallelograms?
Yeah, well, it's on the quadrilateral page.
I don't think that's it. What did you say? Lesson 60?
Yeah, but no, let's do
57.
54 or investigation 3.
Oh, I'm in the wrong page again.
What are
Oh, no, I don't have
I
I don't have the
parallelogram.
Take out your notes under parallelograms because we are going to jot this down here. This will make your life maybe a little simpler on them. Let's see, 54. Oh, it is. It is our. It is our. But anyways, write this down under parallelograms. because this will make your life so much simpler, Carter.
Probably.
Maybe this was 6th grade that we talked about this. If it is a parallelogram, first of all, opposite angles are equal. Okay, which means this. Okay, if I am just looking at this parallelogram right here, opposite angles, like we talked about, this 61 degrees is equal, which means this angle also equals this angle here. Okay? That one, maybe everybody got, but here's one that maybe we probably should have written down, and I don't know if I missed it or if the second thing is adjoining or angles, what do they call it? Adjacent angles. Oh yeah, adjacent angles. Adjacent angles are supplementary, which may or may not mean anything to you. And by supplementary, that means they form 180 degrees. They make 180 degrees, a straight line when they're put together. Which on this one would help you dramatically because, okay, this angle and adjacent angle, they share the same side if they're adjacent, okay? If it's a parallelogram, adjacent angles are supplementary, which means what number plus 61 gives you 180 degrees? That's where 119 comes from. See, 61 is adjacent to that one, 61 is adjacent to that one, so this is also 119 degrees. Adjacent angles are supplementary and they make 180 degrees. Maybe we did that. Maybe we did that under transversals. That should help you out in that. Opposite angles are equal and adjacent angles are supplementary in any parallel. Jot it down for your notes for tomorrow. Other questions on that? Carter Westfall, another one?
How do you write 13 as a percent? But I got the decimal right. I got 0.416. Sure, this needs a percent.
Well, tell me how'd you change it to a decimal?
I divided 5.000 divided by 12.
So you took 12 into 5.00, right?
Yep.
All right, so watch up here carefully. Okay. Yeah, thank you. Okay. The first two digits after the decimal are your percent, are your whole number percent. In other words, 12 goes into 50 4 times, that's 48. Subtract. 12 goes into 20 once, right?
Yep.
That's my whole percent. Whatever I have left after that is the fraction of a percent. I take my 12, 1 times 12 is 12, I get 8. I don't write it as a decimal, I don't write it as a remainder, I make a fraction out of the 8. 8 gets put over 12, and that is my percent. You just need to reduce that before it goes into both of those two equations.
Percent.
And that's what it is. Because we don't like to mix decimals. I mean, you could put this down, but that's really not an acceptable form in math because repeating decimals go on forever and they don't make a lot of sense. Fractions are much more accurate than decimals are, especially when it comes to repeating decimals. So the first two digits after the decimal are your percent, and then whatever's left over you do the fraction. Parker.
Can you scroll up to 2 or 6?
I have to change pages, but I can certainly. 6 must be way at the top of this, isn't it? Yes? Is there a question in that?
just forgot how to do the pen layer.
You don't have to, you just look at a triple.
Oh, yeah. But, like,
There was no 1024, so we look for a smaller ratio triangle, which means if I cut these both in half, I ended up with a 5 for my small one and a 12. Half of 24 is 12, and there is a 5, 12 up here. 5, 12, 13. So the small one has 13 for its hypotenuse, but I have to double it again to get back to my big one. It's all an equal ratio thing. You're not going to believe this, but Carter has another question. Yes, sir.
I got 18 right, but I want to know.
But you want me to do it just because you feel better.
Well, I just want to know how, like, I get.
How you got it right?
Yeah, I got it right.
So tell me what you did.
All right. I want to write it down first.
When you multiply, by the way, this is scientific notation. What do you do when you multiply scientific notation? Again, this would be something I'd write in my notes if I got it wrong. First thing you do is
You multiply 4 times 7.
multiply these two numbers together, and that you get 12. After that, you write times 10 down. Here's where people go wrong. Now what do I do to get the rest of it? I've got 10 to the negative fourth and 10 to the negative third. What do you do with those?
You add them.
Right, you combine their exponents. And the negative 4 and the negative 3 is a negative 7. That's all well and good, except it's wrong until you make it back into scientific notation, which means you have to take the decimal, make this a number between 1 and 10. You have to move it right here and make it 1.2. The problem with that is once you've changed this number, you also have to change that exponent. How do I know what to do with that exponent? If you remember from back in the day when I told you. Abram?
5
Well, because you weren't really looking up your thing, you were actually
I
typing
got it.
something.
I got it right.
But you can't tell me how to do it. You got it right, but you can't tell me how to do it?
Oh, wait. Oh, you're talking about getting it to.
I'm saying I had to change 12 to 1.2. What do I do with that exponent now?
You have to move the decimal to the left.
But
But you said.
Exponent to the
Turning it
left.
0. It's 0.
Tyler?
If you make the number smaller, you make the exponent bigger, and vice versa.
Right. I made it 12 down to 1.2. I made it 1 smaller. So I actually have to make this one bigger to balance it out. And negative 7 plus 1 is a negative 6. So,
Michelle wants to know if you sold the paint pens.
no, I put them back in the art supply closet in the light room in the gym. Probably not supposed to go there, but that's where I put them. Yeah, they're way in the far back. They are there, unless somebody took them.
What is that the answer?
Scientific notation. It's on the scientific.
Other ones.